Hi everyone, myself I am Ajmal Aboobacker. These are my profiles at Hunter and LinkedIn. I known by the username Beef. I'm a computer science and engineering student. It's been almost a year, I think so. I have been working or contributing to Hunter, and I am one of the top 10 Hunter contributors. So here, this is my part 1 video on deserialization attacks in Python packages. Here I will be taking you through how to find a vulnerable package and check whether it is exploitable, then how to build an exploit for it, and I will also specify the way to patch these bugs. So how to find a vulnerable package? Here are the most common vulnerable insecure deserialization code patterns. Usually comes with the Python packages. YAML with a load function, with a load function having a full loader, and pickle load functions. So let's begin with how to find a package with these common code patterns. GitHub, we can use GitHub and GitHub grep.app and CodeQL platforms for finding these bugs usually. So GitHub search bar provides the functionality to look for a specific code in a repo or in all the available repos in GitHub. So here we can search for a specific code and see whether it is available on all the repos. Yeah, these are the repos containing the code pattern we have searched for. Then here we can select languages, specific languages for if you are looking for a specific package or a package with a specific code. Well, like in this video I'll be explaining on the Python ones, so let's check the Python. These are the ones with these code patterns. So let's move to the next platform. Here it is lgtm.com. lgtm.com is a platform where we can use CodeQL queries to look for an occurrence of a specific bug patterns, and at last grep.app. I will explain it later after lgtm. Here at lgtm.com we have to provide a specific CodeQL query which will needs us to find a specific bug pattern like command injection or RCEs. This one here we can either specify a specific project name, or we can look through entire GitHub projects for finding these bugs. So it's all about lgtm.com and at last grep.app. Here we can search for a specific codes in all available GitHub repos. This can be considered as the search engine of codes for GitHub. Likewise, if we give yaml.load, it will show us all the available projects with that code pattern we have been searched for. Like these are Python packages with the YAML function. Here this is not vulnerable. We can go through it and find a package. So let's move to the next phase, checking whether our selected package is exploitable. I would refer you to use Python virtual environment, as it may help you to keep your system pip modules clean and some tools unbroken. So please refer to the Python docs on working with the virtual environment. Here I will be using the repo named NNI and its version 2.0, maintained by Microsoft open source projects. NNI refers to Neural Network Intelligence. It's an AutoML toolkit. You can read more on it at github.com/Microsoft/NNI. And here creating an exploit for the YAML.load function. The most common payloads that we use here are these ones, and there are more payloads on this link provided here, because it's issues on PyYAML and YAML function. Here we have to provide our command that is to be executed while loading the YAML file, and here also. So let's check how a package can be exploited which have an insecure YAML load function. As you can see, I have installed the NNI package 2.0, and I have been under the test version of Python virtual environment. I have named it the test one. So let's get to the package. These are the code for the these are the files under the NNI package. So let's open it up in a Visual Studio Code. At first, here we have to search for our vulnerable code. Load. So at first we have to search for the files holding the vulnerable code. Here we can see the files holding the vulnerable code. Then we have to look for the input provided into the code. That is the file. Here the file is named the input that is being provided into the vulnerable code. As you can see, a file is being opened in read mode with the name file and directly provided into our insecure code. It's opened in read mode, so this file is reading this. So this file holds all the content in the file path provided here, and it's being directly provided into our insecure code. So let's get its function and name and check whether it's being used anywhere in the program, and trigger a code execution from there, so that it would be easier for us to get a code execution from that endpoint. So let's copy its function. Here we can see the files that is calling this common utils files and the get YAML content function. Let's check each file. While going through this, we can find this one being interesting. That is, it's a config path that is being directly provided into our exploitable function. So I think it will be easier for us to get a code execution via loading an insecure and exploitable payload included YAML file. So let's get to this one. So let's see platform clean arguments. This one is using a system argument. So one of the argument provided to the binary is being directly loaded into this config content file. Here we need to provide the config path. So let's check where is this one being used, and it's a as we can see, it's a config content. So let's find out, is there any config is there any config arguments being passed directly into the NNICTL binary. So let's read its documentation. It's installation of NNI. Yeah, here we can see that NNI is directly calling a config as it through an argument parser mechanism. As you can see, a config file is directly loaded into the NNI binary. So I think our exploit will be working here. At the control of config. As you can see, I think the argument we have provided is directly loading into the config path, and the config path is directly loaded into our exploitable function, this one, and that after loading the config file into this, after opening the config file in read mode, all the content of the config file will be in this file, and this one is directly loaded into the YAML loader. So our payload start working. Here this one is Python exec. This one uses Python exec to get the code execution, and this one uses Python eval to get the code execution. So let's build an exploit. So let's get started building our exploit file. I will let's keep the exploit simple to understand and easily recognizable by others. I will be building an exploit file which will be only working with the NNI 2.0 versions. So in the file I will be including the installation process too. After installation process, we have to create and embed our payload into a fake config file and just load it up with the minus config argument options. So let's get started. Oh yes, and here goes the installation process. As we have already installed it, let's comment it for now, and let's move it up to the payload part. Let's find out a config file which can be loaded into the NNI control. So this one seems to be a YAML file which can be loaded into a load plus a config file. Now it's much more bigger, I think so. Let's make it simple ones at first. Yeah, let's take this one. I think this is an example config file being used in the NNI. As you can see, this is a string name named all name. So let's add our payload here. So payload goes here. Sometimes we have to specify the tag name, else the loading of the file may get errored, because during some loading times YAML is configured in a way that it cannot be started with a constructor tag like this. So we just need to provide a constructor name and provide the payload behind that. So we have made a payload, and let's save it to a fake YAML config file. Open. Config YAML in write mode. Write and read. Let's be there. No, we just need only write. dot write of our payload. So here we will be writing the payload directly into the fake config file. Then at last we need to just check whether it's working or not. So let's call our nnictl function. Now let's get our fake configs path. Change the home directory or use an environment variable like $home to avoid these ones. Let's check whether our exploit was working or not. Oh, it's getting some kind of errors. Let's check what it is. Oh, we need to provide an option to as we can see at NNI, we need to provide an option either to create or train a model, something like that. Yeah, so let's provide an option to create. Oh, please set correct config path. We need to check whether fake config.yaml. Oh, as the exploit is being running in the same directory of our same config file, we can avoid the path being mentioned here. And our file name is wrong. Yeah, we can see that we have got a code execution here while loading a fake config file into the YAML load insecure YAML load function in the NNI project. So let's patch it up. So let's patch it up. Sorry for this noise. Yeah, patching. Either we can use the safe load function or the safe loader function to patch the loader or the full loader. Both the loader function and the full loader function is exploitable. I have forgot to mention it here. So here it's the loader function. We need to find the YAML.load. And there is one thing to while using a full loader or a loader function, we cannot use the safe load function, so we need to use a safe loader. Safe loader function to patch this one up. This one here it is too vulnerable. Let's check this one is being working correctly or not. Yeah, we can see that it's a constructor tag error, so our exploit has been failed due to the availability of the Python. Due to calling of that Python payload via our exploit file, as you can see, it's starting with this one. This is being mentioned as the constructor tag here. So our exploit fails and our patch works. As I have mentioned earlier, we should use a safe load if we should only use the safe load if the YAML.load function is not having a loader function, or if it have a loader function, then we have to use the safe loader function or any other kind of loaders like ordered loader, and there are more loaders. You can read the YAML like docs for that. And thank you for watching my video.